0.1 molar hydrochloric acid solution was added to 30 mLs of barium hydroxide. It took 35 milliliters of HCl to reach the equivalence point. What was the original concentration of barium hydroxide? So a couple things. First of all, you won't actually find this question in the notes. So if you want to work on this yourself, go ahead and pause the video and try this out on your own before you watch me do this. So that was your chance. So now, what we do have in this problem, so one, even though it doesn't explicitly say titration, it does have words like equivalence point in there. And it does also tell us that we do have some sort of acid solution. So we do know that we have HCl as a strong acid, and we do have our barium hydroxide, which is a strong base. So we have some information. And what it actually wants us to calculate is the original concentration. So the grand question is, what do we actually know? Well, if we know the equivalence point, what the equivalence point tells us is the equivalence point tells us that my moles of my H plus has to be equal to my moles of my hydroxide, which is a great place to start. So I can get this number. So let's go ahead and do that. So I can take my concentration, my molarity of my HCl, and multiply it times the volume of my HCl, 0.035 liters. And that'll get me 0.0035 moles of HCl. Now, a step that we've been taking out, but it's important to remember, since we know that HCl is a strong acid, that means it disassociates 100%. So whenever we have moles of HCl, we can automatically say that my moles of HCl is going to be equal, my HCl will be equal to my moles of H plus. So again, that's a step that we've been skipping over because it's just always been this lovely 1-to-1 ratio of my HCl to my H plus. And with a strong acid, we've just moved on. But this is worth mentioning because of the next step we're about to do. So we have moles of H plus. And since we're at the equivalence point, we know that this then has to be my moles of my OH minus. But here's the kicker. Moles of OH minus is not the same as the moles of barium hydroxide. So if you look at barium hydroxide, it's also a strong base, but for every 1 mole of my barium hydroxide, I get 2 moles of hydroxide ions. So what that means, thinking back to a time when we did stoichiometry, I've got my moles of my hydroxide, and there's 2 moles of my hydroxide in every 1 mole of my barium hydroxide, which basically means you divide the number by 2. So once I do that, then I find I've got 0.00175 moles barium hydroxide. So this is often the part that gets kind of confusing, is you've got to take into account the relationship between your hydroxide and your barium. So you've got to kind of keep an eye on what they're actually asking for and what you actually need to do to the number. So this is where you've got to kind of pull out of your tool belt ways that we can deal with our dibasic bases. So we've got our moles of barium hydroxide. That's not what they asked us for, so we actually got to go back to the problem. And what do we actually need? Original concentration. So since we wanted the original concentration, we're actually going to be using the original volume of barium hydroxide. This is also kind of another weird little trick that we can do. If you want the original concentration, that means that we're trying to think back in this problem where we had a little beaker full of our barium hydroxide and we had a little beaker full of our hydrochloric acid, and we combine them together into one giant beaker with this huge volume. But so oftentimes we ask you guys about the final conditions, but we can ask you about one of the original. So This is where you can't just run on autopilot and assume that all those words in the problem are just worthless. Nope, you actually need all those little words. So original concentration means we need the original volume, and there it is, 30 milliliters, way up at the top, 30 milliliters of barium hydroxide. So then I can come all the way back down here. I've got my moles of barium hydroxide, and I can put that over my original volume, which is 0.03 liters, and that'll get me an original volume, 0.058 molar barium hydroxide.